Hello, this lecture is about Korean government policy for industry-led ICT R&D. Let's start with a brief introduction about myself. My name is Sang-won Ko, and I'm an economist. I received my doctorate degree from Cornell University in 1992 and has worked for the Government Research Institute. Let's start the lecture. As of 2017, Korea's business ICT R&D intensity, which is light blue bar in the diagram, is almost 2% of GDP, only behind Israel. The business ICT R&D intensity is the second highest in Korea among OECD countries because of huge R&D expenditures from large firms like Samsung Electronics and LG Electronics. According to industrial R&D investment statistics compiled by EU, Samsung Electronics ranked number 4 among top 10 R&D spenders in 2019. Only Alphabet, the holding company of Google, Microsoft, and Huawei spend more on R&D than Samsung Electronics. LG Electronics ranked number 55. Large input R&D investment was translated into large output, patent and trademarks. As you can see in the picture, from 2014 to 2016, Samsung Electronics was the number 1 patenting company, and LG Electronics was the number 1 trademarking company in the world. The Korean firm's rise as top R&D spender has followed a typical path of technological observative capacity building. It followed the sequence of catching up with foreign technology, pursuing indigenous R&D to improve and assimilate imported technology, and to generating one's own technology. The government policy helped to create technological competencies of firms. The government built technological infrastructure and fostered an innovation-friendly business climate. Like Korea, the developing countries can upgrade their technological capabilities in ICT by tapping into globally available knowledge and technology, import of equipment and goods, multinational corporations, and skilled diaspora are important sources of foreign knowledge and technology. Now, I'd like to explain the economics of government R&D. There are 3 rationales for government intervention on R&D. First, knowledge is a public good and has a positive spillover. So when left alone, the private sector underinvests on R&D. Second, under monopolistic market structure, firms do not compete for R&D. In this case, government can intervene as a facilitator of R&D. Third, government intervention can overcome lock-in of existing technology. There are 2 consequences of government R&D. First, it may substitute or complement private R&D. Naturally, you want complementarity rather than crowding out of private R&D by government R&D. Second, government R&D shift both the marginal cost of capital curve and the marginal rate of return curve faced by private firms. This diagram is marginal rate of return curve, MRR curve, and marginal cost of capital curve, MCC curve of R&D. MRR can be think of demand curve, I thought as a demand curve, and MCC is a supply curve. And at the intersection of MRR and MCC curve, which is R star in the picture, you can find the optimal level of private R&D investment. When there is spillover from government R&D, or government R&D supply technological infrastructure for firms, or government R&D lowers risk for firms by signaling future demand, MRR curve will shift upward. So you're going to have more R&D with this shift. And when government pays for the construction of R&D infrastructure or R&D funding to SME work as a signal of quality, MCC curve would move downward. So you're also going to have more R&D with this shift. When government performs research that the private sector would have done anyway, or when non-funded firms should compete with funded firms, MRR curve would shift downward. So you're going to have less R&D, private R&D, with this kind of government intervention. When government make R&D resources less available for private sector, MCC curve will shift upward. So you're going to have less private R&D with this kind of government intervention. In theory, the R&D of the government should stimulate the R&D of the private sector rather than counting it out, which can be achieved by clearly dividing the role of private sector and the public sector in R&D. That is, the ICT R&D should be led by the private sector, and the government must focus its R&D investment in the areas where the private sector cannot undertake R&D or where there is no incentive to undertake R&D. The priority of public ICT R&D in theory should be given to the following areas where the private sector cannot carry out. R&D in areas that entail high risk in terms of the time or finances. R&D in basic research areas required to create new future technologies and pioneer R&D. R&D aimed at effectively transferring the result of basic researches to the private sector. R&D in areas closely related to public interest. And interdisciplinary R&D and large R&D that the private sector cannot afford to undertake. It is true that Korean government play a key role for developing technologies such as TDX, CDMA, and Vibro through large-scale government R&D investment. Nowadays, the focus of government R&D was reoriented towards to solve problems related to quality of life and to support R&D efficiency of small and medium-sized enterprises. This slide shows ICT R&D innovation strategy under iKorea 4.0 policy. iKorea 4.0 policy is a corresponding initiative to Industry 4.0 or Fourth Industrial Revolution. This strategy redefines Korean government role in R&D from an active player to a facilitator. The direction of ICT R&D strategy was reoriented to three directions: investment in high-risk and challenging ICT core technology, on technology that solve people's life problems, especially in the area of city, transportation, welfare, environment, safety, and national defense, and on technology that supports technological innovation for SMEs. And this is the end of the first segment of the lecture on policy for industry-led R&D, the case of Korea. Thank you.